Okay, so in this video, I'm going to be showing you guys how to solve a system of equations when none of the coefficients are the same, or what to do when you have nothing that's able to eliminate. So the first example, and I want you guys to copy this on your notebook, will be this. You have 2x minus 3y equals 12, and 3x plus 9y equals 18. So when you look at this problem, the first thing you notice is that none of the terms are going to eliminate. So what you do is you want to multiply the first equation by the coefficient in the front of the second. So basically I'm going to multiply this first equation by 3. So every term in the first equation is going to be multiplied by a 3. And then the one on the bottom, or the second equation, you're going to multiply it by 2. So this second equation, every single term is going to be multiplied by the 2. So our new set of equations are going to be 6x minus 9y equals 36 for the first one. And then our second one becomes 6x plus 18y equals 36. Now, here we notice that we do have the same coefficient for the x values, but they don't eliminate. They're both positives. So as we learned last week, we're going to have to go and change every single sign on this second equation. So instead of a positive 6x, I'm now going to have a negative 6x, negative 18, and a negative 36. Now I can go ahead and eliminate the terms. So when I add these two equations, the 6x and the negative 6x go away, they eliminate. I have a negative 9y plus a negative 18y, which becomes negative 27y, equals 36 minus 36, which gives me 0. Now at this point, divide both sides by the negative 27. And we have that y equals 0. So we found our first value for our coordinate point. We know that y equals 0. But remember, you still need to find that x value. So the next step, just like we learned already, we're going to go back to the original equations that we had, and you're going to substitute this y equals 0. You're going to substitute it into one of the equations, whichever one looks the easiest. So I'm going to pick the first equation. We have, remember, you want to rewrite it so you know what you're working with. So you have 2x minus 3y equals 12. But now I know that I have y equals 0. I'm going to go ahead and substitute that in for y, which gives me 2x minus 3 times 0 equals 12. Now go ahead and solve it to find what x equals. So we have 2x minus 0, or this goes away, equals 12. Divide both sides by 2, and you get that x equals 6. So we know x equals 6. And then ask yourself, what type of lines are these? If you know you have a coordinate as your answer, then you know they're intersecting lines, and you know this is where the two lines intersect. So for this answer, we have 6, 0 is our coordinate point, and we have intersecting lines. So the only difference for today's problems are going to be, what do we do when none of the terms eliminate, or if they all have different coefficients? And remember, all you're going to do is multiply the first equation by the first coefficient of the second one, and then vice versa. You're going to multiply everything on the second equation by the coefficient on the first one. So let's go over another example. So make sure you copy these down on your notes, on your notebook. Let's try one more example. Okay, so the second problem I want you guys to do is 2x plus y equals 7, and then 6x minus 2y equals 6. 6x minus 2y equals 6. So again, you look at the system of equations, and then check, does anything eliminate? First of all, in the x's, we have a 2 and a 6. Those do not cancel out, or they don't eliminate. And then for our y terms, we have the 1 and then a negative 2. So we notice that those don't eliminate either. So what you want to do is look at both of the coefficients in the front. So we have a 2 here and then a 6 here. Now what you're going to do is you're going to multiply everything on the top one by this 6, and then every term on the second equation by this 2. So go ahead and multiply that out, and you get 12x plus 6y equals 42. And then for your second equation, you get 12x minus 4y equals 12. Now that you've multiplied everything, go ahead and check. Now do I have anything that eliminates? If not, we're going to do what we did last week. We're going to force it. So for the first term, 12x and 12x, those do not eliminate since they're both positive. And then for my second terms, that's a 6 and a 4, so we know those don't eliminate. So what you're going to do is, again, change all the signs of the second equation. So this becomes a negative, this becomes a positive, and this becomes a negative 12. So now go ahead and solve the system, or add both equations. So once we add them up, the x's cancel out or eliminate, and then you're left with 10y equals 42 minus 12 is 30. Again, divide both sides by 10, and you get y equals 3. So again, you know that you already have half of your coordinate point. The y value is 3. Now go back to your original equations. Which one looks the easiest to work with? So I'm going to pick the first one since they're all positive terms and it's easier for me to substitute. So I'm going to pick the first one. So copy it down again. 2x plus y equals 7. Now I already know that my y value is 3, so all you're going to do is substitute that value for y. So now that gives me 2x plus 3 equals 7. Solve the two-step equation. Subtract 3, subtract 3. You get 2x equals 4. Divide both sides by 2. You guys should be experts at this already. X equals 2. And that's it. You have your coordinate point. So my x value is 2. This is my coordinate point. And again, if your answer is a coordinate point, you know you have intersecting lines because this is where both lines meet or where they both intersect. So these are also intersecting lines. So we have intersecting lines, and this is the coordinate where they both intersect. Let's try one more example. Let's see if we can go over an example with a special case. But everything, again, pretty much works the same way. You first want to check your system, and then does anything eliminate? If not, then you're going to do these rules. So the next one we're going to try is negative 12x minus 8y equals 2. And then for the second equation, we have 6x plus 4y equals negative 10. So again, check all the coefficients. Negative 12x and 6x. Those do not eliminate. Move on to the next one. Negative 8y and positive 4y. Those do not eliminate either. So then you're going to look at the coefficients of the first one. So we have this 12 and the 6. So you know you have to multiply the first equation by a 6 and multiply the second equation by the 12. Notice how I have a negative 12 on the top equation, but I'm just going to multiply it by 12. Multiply every single one by 12, and then we'll see what we do with the signs. So here we have 6 times negative 12 is negative 72x. 6 times negative 8 gives me a negative 48y. And then 6 times 2 gives me 12. So that's our new first equation. And then for the second one, 12 times 6 is 72x. 12 times 4 is 48. So I have 48y. And then 12 times negative 10 gives me negative 120. So that's my new set of equations. Now check, does anything cancel out? Notice that in this one, we don't have to switch any of the signs. We already have negative 72 and positive 72. Those eliminate. And then we have a negative 48y and a positive 48y. Those also eliminate. Now when you have both of the variables eliminating, you know you only have 0 equals, in this case we have positive and a negative, different signs subtract. 120 minus 12 gives me 108. The 120 is bigger and it's a negative, so you know you have 0 equals negative 108. Now this is a special case since we don't have any variables left over. 0 equals negative 108 is a false statement, so you know this is no solution. If this is no solution, then these lines are never going to intersect. So you know they're parallel lines. So for the types of lines, you're going to say parallel lines. And that's it. And there's no coordinate point because you know these lines never intersect. So go ahead and make sure you've copied these down on your notebook. And that's it for today. Thank you.